So before I move to number 15, let me make a quick note about number 14, okay? The only thing that might trip you up is the last bit that says a times a. Remember how we write that in exponential form? Would be a squared because it's multiplication. Now, you cannot combine a squared with an a because they're not the same thing, okay? So a squared and a are different. Don't combine those terms, all right? All right, number 15. Number 15 says using x and y, write two different expressions that are equivalent that represent the perimeter of rectangle 1. Now, there's two things we remember about perimeter. Perimeter, we have to add all the sides. And if it's a rectangle, we know that opposite sides are equal. All right, so that means the opposite side of 4 is also a 4, and the opposite side of 2x plus y is also 2x plus y. So guys, I'm going to give you 3 different expressions, okay? 3 different equivalent expressions to the perimeter. So the first one, guys, I want you to go ahead and just take out every side and add them together. So that means 2x plus y plus 4 plus 2x plus y plus 4. This is considered an equivalent expression. So this represents your perimeter. Okay. Another way we can come up with an expression that is equivalent to the perimeter is actually combining like terms. So if I took 2x and I combine that with any other x, I'd get 4x. Same thing with a y. I'm going to give that a different shape. A y plus a y, you get 2 y's. And then a constant plus my constants, 4 plus 4 would give me 8. All right, this is also an equivalent expression to the perimeter of the shape. All right, for the last one, you could also take the coefficients and the constants and find the greatest common factor to place that expression into distributive property form. So I took 4, 2, and 8, and I put them in my ladder. The only number that goes into all of these numbers is 2. So I'm going to take out the greatest common factor of 2 and simplify. 2 goes into 4 twice, into 2 once, and into 8 4 times. So I'm going to take this and place it in distributive property form. Remember, we do that by parentheses, and then the GCF is on the outside. So my GCF is 2. I'm going to have 2 plus 1 plus 4. So I've got 2 plus 1 plus 4. However, this 4, 2, and 8, not all of these were by itself. So if we look at number 2 for our equivalent expression, the 4 was next to an x, and the 2 was next to a y. That means that each term down here, this 2 simplified from 4, that means it must have an x right here. And I know I ran out of space. I'll rewrite it over there. This 1 simplified from the 2, which had a y, so that must have a y as well. So I'm going to rewrite it using distributive property form over here. So 2 parentheses 2x plus y plus 4. If I double check this by distributing, 2 times 2x does give me 4x, 2 times y would give me 2y, and 2 times 4 would give me 8. So all 3 of these expressions are equivalent to the perimeter. All right, and again, number 16 is exactly like number 15. All right, so I'm going to move on to number 17. All right, number 17 says which rectangles below have the same area. Now, there's one thing that you need to remember about area, right? And we basically said that area is equal to length times your width. All right, so I'm gonna go ahead and label my rectangles. I know they're actually misnumbered, which is okay. We're gonna use those labels real quick. So number 2, get 10x plus 6 and 4. And then number 4, we've got 5x plus 3 and 8. Now, I'm going to go ahead and label the lengths and widths of each rectangle, okay? So my length here is 2 and my width is 3x plus 2. If you guys can see that. Number 2, the length is 4 and the width is 10x plus 6. Same thing for number 4. 8 is the length and 5x plus 3 is the width. So I'm going to take my length for number 1 and I'm going to multiply that length by the whole width. Now, the way we can do that, since this is not one number, we're going to put that in parentheses to represent one whole term, right? So now this looks familiar. It's actually a distributive property question because it's area. So I'm going to distribute 2 to everything in the parentheses to condense my area. So 2 times 3x gives me 6x, and 2 times 2 gives me 4. So that's the area for rectangle 1. All right, same for number 2. I'm going to take my length and I'm going to multiply that by my width by distributing 4 to everything in the parentheses. So I get 40x plus 24. So these two are not equivalent. So let's check number 4. All right. Number 4, I've got a length of 8 times the width of 5x plus 3. I get, if I distribute, I get 40x plus 24. So the two that have the same area would be rectangles 2 and rectangles 4. All right, and then the last problem, number 19, we've got Kaylin can find the volume of a cube by using the formula V is equal to S squared. However, that is a typo. The volume of a cube is actually S cubed. V is equal to S cubed, but we're going to use both. So I'm going to show you both for this one. All right. So it says where S represents the side length. So S is side length. Let's see if they give me side length. It says that if Kaylin's cube has a side length of 5 centimeters, what would be the volume of her cube? So this is a simple substitution problem. So I'm going to rewrite it S with 5 for S. So meaning where I see this S, I'm going to write a 5. So 5 squared. So this is exponents. If I expand that, I get 5 times 5. That means that my volume is actually equal to 25 centimeters squared. Okay. If the formula for volume was actually correct, it should have been V is equal to S cubed, which means, I'm going to rewrite it over here, V would equal to 5 cubed, right? We're just plugging in 5 for S, which means that that would be 5 times 5 times 5, which means that 5 times 5 times 5 would give me 125 centimeters cubed. So I would take both of those as your answer. Just double check that the exponent is correct on your study guide, okay? All right, good luck, and I'll see you guys today. Bye.